Welcome to Insider's Viewpoints, the importance of design and software architecture. In this video, we will hear from experts discussing the importance of design and software architecture in a software engineering project.
Design and architecture are crucial. If you don't know where you're going, how do you know what you need to do now? You always need to know what your program needs to be prepared to handle and the system that it's operating within. If you are running if you're running a bunch of applications that are all co-hosted on the same server, you can make certain assumptions about the ways those services can interact with each other that do not hold.
I also sometimes think of architecture and orchestration. So you can have like a beautiful, really nice sounding instrument, but if it's not in sync with the rest of the orchestra, it's going to sound like a complete cacophonous mess in the end. So you really need to think about the bigger picture, sustainability, whether what you're building actually makes sense in the larger sort of ecosystems.
And every time, if you spend the time to write your code and then you figure out why it doesn't work, you've wasted a lot of time writing that code. Maybe you've learned some things, it's not a total waste, but you've spent a lot of time that could have been spent moving forward. And so if you can think about those things ahead of time on a project, and then when you write your code, you're reasonably sure that the code you write is actually going to persist and get used, that's generally speaking a better place to be in. So architecture is very important.
There's a lot of talk about its scale, global availability. Often something you build would work very well in a very hyper-local environment, but not work well when it's expected to be used across the globe, or works well for one user but doesn't work well for a million users.
I'm building the service. I need X, Y, Z pieces of data to come into the function that I want to write. Where are those things coming from? How are they getting passed in? Once I have them, what do I need to do with them? What else needs to access this data? And how am I going to get the data to those other parts also? And if you don't have those questions answered, you end up writing a lot of churny code. If everything is on a separate server somewhere in the cloud, or separate physical servers that are just located somewhere different inside your data center, then you have to incur a network hop to go over them. And that takes time. Your page might start timing out, and your customers might get really upset at you for how long things take. And so if you're building something in like a microservice architecture, the way that you load your data becomes much more important than if everything is hosted together on the same server. But maybe the question of who is using my service? How do I know who you are? That can become an interesting question depending on where your services are running, and what mechanisms are available to you to identify people. If you want your customers to log into a website, how are you doing account management? How do you know who that person is and what they're allowed to do? Or if you have multiple services talking to each other, again, how do you know what that service is, what it's allowed to do? How do you make the call between one and the other? How do you transmit data between different parts of your stack? So architecture is very important. It doesn't always have to be super well-defined, super strictly defined, but you need to have some idea of what things do you need, roughly where they're going to live, and what are they responsible for? Those would probably be the three big questions to ask: what, where, and scope of them. So
these sorts of concepts, you have to think about those things when you're designing or architecting a system. You're thinking like 5-10 years ahead too when you're thinking about architecture and design. You're not thinking about just building something quickly and getting it up. You actually want to plan ahead. So I think a lot of architecture and design is thinking about, how many steps, how many years, whatever in the future, what is it going to look like then? What do you need to do to keep growing the system and evolving it? Because you don't want to make gigantic architecture changes that often. You don't really when buildings are repaired, there's like tiny bits of things get repaired, and then at some point you tear the thing down and rebuild it. And I think that's a similar model applied to sustainable system architecture. You don't want to re-architect and redesign every few years. You want it to last as long as you possibly can.